Hello friends, I am Deepak Raj from A department. Today we see the topic about the usage of carbon nanotube in reducing power loss in transmission wire. First of all, we see the introduction. Increasing use of technology in all areas of our daily life had been immense effect on our demand for electrical energy, and this has resulted in the urgent need to find more efficient methods for its generation and distribution. This need has stimulated the quest for new materials and highly efficient devices, which have significantly better performance than those currently in use, as well being cost effective, safe, and environmentally friendly in the perspective. Carbonides are very promising material. The recent synthesis of fluorescence, carbon nanotubes, and the separation of graphic has generated enormous interest in this carbon's material. Moreover, the fibers should considerably exceed the performance of any material used currently in electrical engineering in terms of mechanical and thermal properties, while keeping the density very low. The bestest made CNT fibers had needed excellent mechanical performance, which is superior to any conventional conductive material, and they have very low density 2-3. However, the electrical conductivity is still below aluminum and copper 378. This is lower electrical conductivity, which stems from a limited control over the morphology of the CNT and CNT fiber welding. Extensive application of monotubes for electrical wiring. Properties of currently produced CNT fibers and the potential of CNT fibers with respect to electrical wiring applications. The paper examines also the challenges in the area of CNT wire research and suggests some possible solution to issue arising. The paper is divided into 8 sections represented schematically in figure 10. Open in figure, viewer PowerPoint schematic diagram representing the table of the contents of this future paper. The number is black circles corresponding to the section number. Second topic we are going to see is the individual carbon nanotubes. Structure of and classification of the structure of carbon nanotubes is based on a planar hexagonal lattice of carbon atoms called graphene, rolled to form similar tubes. Depending on how the graphene sheets are rolled into nanotubes, which is referred to as CNT chirality. The following three basic types of CNT structures are distinguished. They are zigzag. If the hexagonal lattice from zigzag pattern along the circumference of the nanotubes, armature in which the lattice is turned around by 90 degree with regard to zigzag pattern, and chiral and when any pattern appears along the circumference. Methods of synthesis. The basic methods of synthesis of carbon nanotubes includes laser ablation, arc discharge, and chemical vapor deposition. The first two involve the evaporation of carbon molecules from the solid, whereas CVD method cracking the hydrocarbon process. The carbon atoms get recharged into a desired nanotube structure. The method requires high temperature to initiate the process and maintain the CNT growth. Most CNT fibers are produced out of the nanotubes obtained via CVD route. Properties and individual carbon nanotubes are type of quantum wires. The third topic we are going to see is the three assembles of the carbon nanotubes. During the synthesis process, certain often spontaneously assembled into bundles due to van der Waals interaction. The phenomenon was also observed for Daunt and Mant and the mixed types of CNT. In severe synthesis condition, bundling provides genetically for individual nanotubes. Transmission electron microscope image of the bundle of cement is presented in fiber. The fourth track we are going to see is carbon nanotube fibers. The wet methods rely on extraction of liquid solution of nanotubes into bath with a congruent which is required that can mix the solvent but cannot disappear nanotubes. The CNT therefore get precipitated in the form of long fibers. There are basic spinning approaches reported, that is spinning out of the liquid crystalline suspension of cement in pressurized movement in the ethylene glycol out of the surfactant stabilized suspension, which normally use sodium and lithium dioxide sulfates as surfactants. Out of the suspension they prepared with the aid of molecules, for example DNA and hyaluronic acid. Figure 13 in figure viewer point, a system used by Ericsson at 50 to spin CNT fiber from liquid crystalline phase. Fiber extracted from capillary tube. CNT fiber would wound a rotating spool reproduced permission. The direct spinning of CNT fibers from the CVD reactor is shown as the vertical arrangement of the reactor is shown as an example. However, it may be as will be oriented horizontally. In the direct spinning process, the feedback comprising hydrocorrections. For instance, a sulfur compound and hydrogen is introduced into the hot zone of CVD furnace. The furnace becomes a source of ion catalyst cluster whose size is controlled with the aid of sulfur. Among the two steps, dry methods of CNT fiber production, the most widely applied in that of the drawing of the fiber CNT vertical arrays 62, 64, 68. In the first step, the forest are prepared using CVD technique. In order to obtain CNT forest, the catalyst particles are placed on a substance which is inserted into a furnace. The hydrocarbons are introduced into the furnace with the flow of the carrier gases such as mixture of the 5-mol acetylene and helium. The synthesis takes place in the hot zone, the reactor normally at temperature above 600 degrees. The process taking place during the drying of the fibers from the arrays is not yet fully understanding. However, it is known that all the arrays are spinnable. Such as factors are overweightness of CNT, improved length, the presence of impurities were suggested as factors which prevent the formation of continuous fibers. The existing theories indicates two potential explanations of mechanism of spinning CNT fiber from CNT arrays. Thank you.